warm-up time. We have this question that's on the board where you're given a graph and you have to formulate the inequalities based on the graphs that you see. Right here I see two different graphs. So the red equation is going to be with this graph right here, and the black equation that's written on this paper will be this equation down, or this inequality down here. So what I want to do is I want to start off with what is the correct equation that I should write. I'm going to put it in slope-intercept form. So with the red graph here, I'm looking at the intercept right here is at 3. And then I find my next good point, so I'm going to go ahead and travel down, and I'm going to go to the right, and there's my next good point. So I know that my slope is going to be negative x plus 3, because you have your slope, and then you have your y-intercept. It's a slope-intercept form right here. I know that I'm going to have y in front of it, and so I have to look at the type of line. I see that this line is a solid line. So that means that I'm either going to use less than or equal to, or I'm going to use greater than or equal to. I see that if I put my hand up here, I'm shading down below the y-intercept. So that means less than or equal to is going to be the inequality that's going to be used. The next one, the next graph we have is going to be the black graph right here. We can see that the y-intercept right here is at negative 3. And we see that this graph goes down 1 and right 1 to this other good point right here. So we're going to have the same slope as this graph right here, just a different y-intercept. When we do that, it lets me know with the same slope and different y-intercept that we have parallel lines. So here we have negative x minus 3. We have y in front, and now we've got a solid line again. That means I'm going to use greater than or equal to, less than or equal to, depending on which direction the shading is going. So I care about what is above the y-intercept. If it's above the y-intercept, it's got to be greater than or equal to. So there's my two equations, or there's my two inequalities from the graph given. We have two other pieces of information that we have to choose from. A critical point. For me, the critical point would be where these two lines intersect, but since they're parallel, they never intersect. So if we don't have a spot where they intersect, you would write there is no critical point, or I'm just going to write none for my critical point. However, there is information here that we can choose from. We can choose any good coordinate point that's inside this shaded region. And what I mean by a good point is that it satisfies not only this inequality, but this one as well. So I know that all these points here, these two, these three, all the way down here, these are all good points. And then if you continue with this graph, you have good points there as well. So negative 3, positive 2 is a good point. So any coordinate point that is inside the shaded region right here, those are all good points. If I wanted to check to see if my graph came out appropriately, I can go to my calculator. I'll go to Scratchpad. Okay, if there's something in there already, clear it out. Menu 1 for enter. And then menu 4-5 gets me back to a standard graph. From here, I'm going to go ahead and plug it in. If I hit tab and I see f of x, I'm going to hit menu 3-2 to get it to relation. And I'm going to go ahead and plug it in. I've got y is less than or equal to negative x plus 3. There's the first graph, and then the second graph is, you're going to hit tab, and you're going to say y is greater than or equal to, and I've got negative x minus 3. Okay, and I care about the darker shaded region, which matches up exactly to the same graph that we have right here. And that is how you do the warm-up when you look for critical points and you look for points that work out. Any of the points that I made on here are good points, so a good point, you just have to pick one. And the first one I gave you was negative 3, positive 2, because it satisfies both of the inequalities given.